Good afternoon. It's a pleasure to be back here this year. It's certainly a privilege. Thank you very much to Ann and the crew here at the conference. This is great, and thanks for sticking around this afternoon. So this session is WebSocket Perspectives and Vision for the Future, and I'm here with my colleague Robin Zimmerman from Kazing. So what we're going to do in this session is that we'll give a brief background on WebSocket. I think most of you know what WebSocket is. I mean, how many of you have used WebSocket already? Okay, it's a little more than half. Okay, so we'll give a little background on WebSocket for those people, especially those people that have not done any WebSocket programming, and talk about how we use WebSocket in a different way than you've probably read about in some of the tutorials online about WebSocket. And then we'll talk about, okay, now what's next for WebSocket other than a simple chat program? And where does it fit in this Internet of Things era that's just about to hit us? And where does WebSocket belong? And certainly I'm going to leave some time for some really cool demos where we're using WebSocket. But to pray to the demo gods and the Wi-Fi gods in the room. So that's me. You'll see that in the presentation slides when you get it. So I mean, we're all here because of HTML5. You know, it's a cool time to be a tech, right? I mean, we have to ride these waves in our careers, and this is another cool wave to ride. And where the web is now changing from a document-centric model to something that's a programmatic framework, right? It's complete change, and it's this really, really cool environment. But we up until recently, we've had HTTP as the only protocol over the web, right? And we know that Tim Berners-Lee invented HTTP back in the late 80s, 88 perhaps, if my memory serves, to basically exchange documents. And it was designed for document transfer. That was its design goal. And it was designed for people to share information. Connectivity was one of the primary tenets, right? All these research documents wanted to be shared. Also, HTTP, it's bidirectional, but you can only send data one way at a time. It's half duplex, right? Data only flows in one direction at a time. And also, we know that it's stateless. I mean, because when it was invented in terms of the state of networking technology at the time, it was designed to be stateless for scalability. There's a lot of benefits to statelessness, but now we're talking about something that's brand new, a more persistent connection. So HTTP, and even HTTP 2.0, which has the speedy protocols as part of it, it's still designed for document-centric things, and it's not really designed for event-based services. And as the internet and web evolves, we're going to see more and more event-based. And we know that when we say event-based, we hear the term real-time. You know, we're not talking about like controlling a nuclear reactor in true real-time. We're talking about event-driven, right? So when you hear someone say, when your manager says real-time, he really means event-driven, right? So here comes WebSocket. So WebSocket, as of 2011, is an official standard by the IETF, the protocol. I mean, the IETF governs the bits over the wire, so it's an official standard. And actually, it's 2 years old. It's coming up on its second birthday. And also, WebSocket is not just the bits on the wire, but it's the API. So the W3C governs the API. There's an official JavaScript API for WebSocket, and it's fairly simple. So what this does is it adds event-based things to the web, right? It's no longer where the user has to activate interaction. And it avoids polling. And we learned back in Computer Science 101 why polling is a bad thing, right? And over time, there have been hacks, I mean lovable hacks, to simulate event-based or real-time with the HTTP. Right? So long polling is one. I'm sure you've heard of long polling. And you can get close to real time by shortening the duration, right? As you shorten the duration, like 10 seconds polling, 5 seconds polling, 1 second polling, you know, 10th of a second, 100th second, you're getting close to real time. But what happens when you do that? The machine starts crying, right? So please don't do that to me. So you have to, your computing resources have to go up to get close to real time. So it's not exactly a good solution. So a WebSocket avoids polling, and it also avoids metadata. So in a typical HTTP conversation, you may have several hundred bytes of metadata. Now, if you're doing some high-performance messaging system, and a lot of enterprises have high-performance messaging systems, metadata is basically redundant. There's no reason to send the metadata. So WebSocket avoids that. And also, it shares the port with HTTP, and I'll explain exactly what that means in a few slides. It's a little, it sounds a little odd, but I'll show you what that means. And WebSocket is a peer protocol to HTTP. So WebSocket doesn't sit on top of HTTP. It sits alongside of it. It's a peer protocol. And they both use TCP, obviously. And we think of WebSocket as being the most important API in HTML5. Now, HTML5 has a lot of cool stuff. I mean, last night, if you guys went to the Leap Motion mini conference last night, there was some really, really cool graphic stuff. And there's a lot of cool web, web audio is amazing. Canvas is a lot of cool stuff. There's so many cool things. But the web was designed for connectivity. That was its primary tenet. So WebSocket is part of the new network stack for HTML5. And as I said, it's a standard from both the bits over the wire, RFC 6455 for those that care, and also there's an API. So WebSocket has two parts. So when someone says they're WebSocket compliant, I mean, you guys have to check them out. It says, are you compliant at the API level and the bit level, the protocol level? Because just having an API doesn't mean you're WebSocket compliant. It means you have a WebSocket API. You have to be compliant from both sides. And to access a WebSocket endpoint, instead of using HTTP:// it's WS://. And also equivalently to HTTPS, there's WSS, and what do you think that does? Secure WebSocket. And of course, in production systems, you want to use WSS. You don't want to use WS. Especially for things like financial services. And it traverses firewalls and proxies, routers securely. And also you can send not only text, but also binary. And it leverages cross-origin resource sharing and CORS, C-O-R-S, as opposed to what the web knew beforehand was same origin, right? You can only go back to the server where you came from. So CORS allows you to go cross domain. So from the browser, you can go to two different domains as opposed to going back. So if you want to start a business based on portal servers, I wouldn't suggest it at this point. So when I said WebSocket shares the same port as HTTP, this is what I mean. So the first connection that a client makes, a WebSocket client makes, is through HTTP. So it makes a connection to a server, and it says, oh, by the way, do you have WebSocket connectivity? And if server responds yes, for example, our product responds yes, we do. We have WebSocket. So it returns an ACK, and then the client says, this is cool. Okay, now I have a WebSocket handshake is complete. HTTP then drops out of the way. So now you have a persistent connection. You have an application socket from the client to the server. So you now have client-server over the web. So now you can have event-based systems talk to your client. No longer do you have to use polling mechanisms. I mean, we've all used Ajax and Comet in the past. Those were all workarounds because we didn't have anything else. I mean, our hats are off to those guys that invented that stuff, but now we're in a new era. Now we have a persistent socket-like connections, application socket to the server. So the world is different now. And as I said, the WebSocket frame, I mean, for most people, this probably doesn't really care that much, but the point is that WebSocket doesn't use metadata like HTTP. There's not the hundreds of bytes that's sent between the client and the server. It's only a few bytes. In some cases, it could be as small as 6 bytes. Now, so also notice that there's an official standard for the protocol, for the WebSocket protocol. And part of the protocol says, here's a WebSocket frame of data. This may not be the only frame that you're interested. So the data that you actually sent may go over multiple WebSocket frames. So when you read a tutorial on WebSockets, they talk about like sending small chat programs. That's a very, very simple case. In a real life, real world case, your data may traverse multiple WebSocket frames. So if you notice that one of the bits in the beginning is, is this a fragment? Do I have to read another WebSocket frame to complete the data? So you have to be aware of that. You know, it's hard dealing at that level, right? I mean, you guys have to be protocol people to understand it at that level. Yet most articles that you read about WebSocket say, here's a chat program. Isn't this easy? No, not quite, not quite. So what WebSocket is not, it's not a new AJAX, right? It's not a new comment. I mean, that's what SSE, you know, server sent events. That's the new AJAX, right? This is not a new AJAX. And it's not just a push mechanism. It's a bidirectional pipe. And it's also a full duplex bidirectional pipe. You can go not only from the server to the client, but backwards. And why is that good? Okay, why is bidirectional good? Well, I could send a message, and then I could send an ACK back. That's important. You could acknowledge that you received the message, which means you can do transactions, which means you can use it for money. That's very important. That's why bidirectional behavior is very, very important. It's not a messaging system. It's a transport for other things to sit on top of it. It's a low-level transport API. Although by having 5 methods in the object or in the class, it seems simple, but you really have to understand protocols to program at that level. And it's not a replacement for HTTP. I mean, HTTP will live on forever and ever past my lifetime. You know, it's great for cacheable data, so it's not a replacement for HTTP. And there's about over 100 implementations of WebSocket. There's many really good implementations. I mean, we have one. ActiveMQ has one. The Node.js and Socket.io, Engine.io, the Plain framework. James Ward and company over there, they have WebSocket. So there's a lot of very, very good implementations. So for event-based things, it seems like a no-brainer, right? You're going to use Websock for event-based things and HTTP for non-real-time. And here's what the API looks like. So you make a connection to a WebSocket just by saying, certainly in JavaScript, because the standard specifies only the JavaScript API, that you say new WebSocket. So the first line there, new WebSocket, and here I just have a URL, www.websocket.org. And then there's a bunch of callbacks on open, on message, on close. And a common rookie mistake is that people forget the on open. Because again, so we're in a distributed programming environment, right? So when you do new WebSocket, you're not on the local machine anymore. So you have to wait for the open. So don't have the second line after new WebSocket start sending data, because the WebSocket might not be created at that point. So make sure the WebSocket's open. And on message, as you would expect, that's when the message comes back to you from a sender. On close, of course, if you want to send data, there's send, and then there's a close sock, as you would imagine. Sounds pretty easy, right? There's 5 method calls. But you're dealing with a streams-based model, right? You're dealing with a streams-based model. It's not at the high level. You're now dealing at the low level. For example, like, how would I do publish subscribe with those APIs? Okay, I do a little more work. How do I do chat? Oh, okay, well, I could send messages, but chat requires things like presence, like to detect when someone's online. How do you do presence? Oh, I got some more work. So this is like what happened like many years ago with Socket. So when Socket first came out, 40 plus years ago, probably the first program was a chat program. Nothing's new in computer science, right? After 50 years. A chat program. The second day, someone says, oh, we need a protocol for a chat program. The same thing happens here with WebSocket. You write a small chat program like with your friends, everything works fine, and someone says, okay, how do you do presence? Okay, well, that problem's been solved by XMPP already and other protocols. So why are we reinventing the wheel? So the second day after you learn about WebSocket, you come up with this question. Everybody does. I need a protocol now, right? Where's the application protocol? What happens if the connection breaks? Who handles retries? How do you handle partial data? right? How do you handle fast data? How do you handle slow subscribers? How do you handle publish subscribe? All these questions come up that you thought, well, this is such a simple API, anybody can do it. But it was designed as a simple API for a reason, to develop other things on top, right? Simple things scale, right? You build on simple things. But if you think about WebSocket differently, think about it as if it's a transport layer, just a clean transport layer on top of TCP, and you have these other protocols that can live on top of WebSocket, which means that if these other protocols were implemented with WebSocket, you immediately can start programming at a higher level. You could program at a way higher API without dealing with all the underlying things like retries and transactionality, partial data. That all is taken care of you by a lower level. So this is a more interesting way of looking at WebSocket. And this is how we're going to move forward. We're not going to move forward if everybody writes at the low level. Just like the world didn't move ahead when we programmed at the socket level. We all went up higher. Why? Because we can move faster. The world evolved faster. So if you have this higher level API, it just makes it easier. You can now do event-based systems. You can take pub subsystems like JMS and AMQP, and you could immediately start writing programs without understanding about WebSocket. And it works over the web. So imagine having an event-based system in JavaScript talking back to your internal ESB, an enterprise service bus in your company. This is very powerful stuff. And this works with standard ports. So in the past, to get real-time behavior, to get event-based behavior over the web with an application, you commonly had to open up a port. And we know that open up a port doesn't endear yourself to the network police in your company, right? You don't want to do that. So this works over standard ports. So this cuts all the complexity out, makes it easier for all of us. We can write programs without thinking about the low-level infrastructure, and it makes our life a lot easier. Right? So simplicity is a really cool thing, and you can show this slide to your managers, right? But what happens? What happens? What else do we need? Well, we're not still quite done. Right? I mean, you can program a lot of this stuff yourself, but what you want to do is that you want to focus on the application. Right? You want to, like, I want to go home at night. I don't want to be dealing with this stuff all the day long and write a lot of code. I like to be dealing with my MIDI system, my guitar at home when I get, right? So there's a lot of things you have to deal with. How do you handle multiple WebSocket versions, right? There's different variations to the spec. How do you handle an older version of the spec, newer version of the spec? How do you handle an older browser? How do you handle IE, right? WebSocket, native WebSocket is only in 9 and 10, or excuse me, 10 and 11. So how do you handle older browsers? Right? If you don't have control of the browsers out there and you have your application that has to hit everybody, how do you handle older browsers? So that's another issue. How do you handle slow subscribers? How do you deal with authentication, authorization? There's a lot of non-protocol, non-API things that you have, a lot of infrastructure around WebSocket that you have to deal with on a regular basis. In any enterprise, whether it's a corporate enterprise or it's a web enterprise, you have to deal with this stuff, right? So what's next for WebSocket? So we have learned that everybody on the planet is now interested in offering APIs, right? The trend's happened for the past like 5 years, and it's now starting to explode. And you can go to like Programmable Web or one of these other sites that lists all the APIs out there. There's thousands and thousands of APIs, and we're now just in the beginning of this. I mean, we talk to large enterprises, Fortune 500 companies. Usually those guys are slow-moving companies. These guys now want to offer APIs outside their corporation for the first time to other organizations. And a lot of them are thinking, how do we offer real-time APIs? Because so far we've been dealing with REST APIs, and I'll talk about it in a little bit. REST is cool for a lot of things. This is remote procedure call that we all know and love for the past like 20 years. It's great. Now it's over the web, over HTTP. This is fine. But now, how do we deal with real-time APIs? That's a good question. And the growth, if you go to Programmable Web, I couldn't find a 2013 graph, but that graph there is just like exploding. And it's not just things like Twitter APIs and Google APIs. We're talking about like a lot of things like market data APIs and authentication APIs and a lot of cool stuff. And certainly the industry is talking about how enterprises in the near future, if you work in a big company, you typically use libraries from internal developers, right? APIs from internal developers, how to do things, how to connect to the database, how to do connectivity, how to do procedure calls, all this good stuff. So now we're thinking that maybe in the near-term future, many of these APIs will come outside of the enterprise, right? And I know your manager might say, like, this is crazy. Security, what about security? I'm going to be going outside. This is nuts. How many of your companies use Salesforce? Right? So the family jewels to your company are outside your firewall. So you tell that to your manager. It's like, oh, that's right. So, so the world is moving towards a composable enterprise where parts are living outside the firewall. But many of these services are real-time services. They're not just like call for something, get the answer back, or excuse me, call and wait for something, get back. It might be event-based. So instead of infrastructure as a service and platform as a service and software as a service, which really is applications as a service, but you can't pronounce applications as a service. That's the reason why it says. Well, you can pronounce it, but it sounds odd. There are other types of what I call everything as a service. So XaaS. And there are things that are not infrastructure. They're like in the middle. They're like in the platform area. But there's like dozens and dozens and dozens of services at that level. Whereas anything as a service, whether it's messaging as a service, to publish, subscribe as a service, that's a common one. Database as a service, storage as a service, these are common ones. But now you get to other things where it's when optimization on it, identity, testing, security. There's a lot of other types of APIs. And a lot of these APIs are not synchronous. They're not naturally REST friendly. They're more event-based. So I think history is going to repeat itself, and in computer science, I think this is a common thing in computer science where history repeats itself. And we know that a while ago, remote procedure calls. This is only maybe 2 decades ago. Remote procedure call was popular, and then to get more efficiency, we came up with asynchronous remote procedure calls. In other words, here's the call. Ping me when you got the result. Have a callback, right? And then we thought about that and we said, you know what? We have all these different things we want to monitor around our enterprise, and we have to have point-to-point connections to everybody. And everyone else has to have point-to-point connections to everyone else. So it becomes a combinatorial problem. So somebody invented a bus, an enterprise service bus, where you talk to the bus and everybody listens to the bus and you get a message from me, hey. So that solved a lot of problems. We still had a need for RPC, for remote procedure calls, but the need for it went down as the advantages of the bus became obvious. Now, programming in an ESB, it's a little more complicated. The complexity is slightly higher, but the benefits far outweigh the complexity. I think the same thing's going to happen to the web. Right? So we dealt with REST because that was the first entree into RPC over the web. And then we have some lovable hacks that some of my friends have come up with. Asynchronous REST, where you have a callback in to get the results. But if in the future, if we had some sort of messaging system, because the way technology works is that things get reinvented and they get slightly tweaked. Right? Like in a cloud, if you go back into mainframe days and offsite database data centers, it's very similar, but it's tweaked. Right? REST, it's like RPC, but it's tweaked. That's typically what happens in computer science. So I think something's going to happen with messaging in the future. So we're probably going to get messaging. We're going to get sort of, instead of an ESB, we'll probably have an ISB, an internet service bus. But the messaging will probably be different from the enterprise. It'll be slightly tweaked, and who knows what that is. Maybe one of you guys is going to invent that and become a gazillionaire. But it's going to be something that's message-based, because it just makes our life so much easier. So what other types of event-based systems other than straightforward enterprise things? Well, we're now entering the Internet of Things era, and I think every large cloud company is promoting the Internet of Things, the IoT, Internet of Things. All of these things are typically event-based. They're all typically event-based. And it's, if you just think about it, I mean, from music to health monitoring, I mean, here you have health monitoring. If you have you have a heart issue, and you want to use a website, you have a web connection, and do you want like 2 milliseconds of latency if you have a heart problem, or do you want like 900 milliseconds of latency? I'll take the 2 milliseconds, please. So there's a lot of cool applications, and I think right now I'm going to turn it over to my colleague Robin to show you some really cool demos.
Yep. Hello?
Yeah.
Can you hear me now?
Yes.
Yep. Okay. Thank you. I haven't actually done anything yet, but I appreciate that anyway. Okay, what I've got is a couple of demos here with a couple of devices. And at first it won't seem very WebSocket related. What we're using here is a Raspberry Pi. It's a little board. I'll hold one up in a minute and show you, but it's only about that big. And it's a little computer. It's sort of like the Arduino, if you know those, although that's just more of a controller. This is actually has more components on it, so it's more like a computer. And it has an SD card on there, and that has an operating system on there, so we use Linux. Linux is the most popular choice, of course. It has an Ethernet cable, so you can get network connectivity. It's got USB cables, ports there. You can plug in a keyboard and a mouse. And it has ports for your screen as well. So you could actually connect a screen and use it as a computer. What I'm going to do instead, I don't have it connected to a screen. I'm going to SSH into it. So we've taken these Raspberry Pi boards, and we've actually got two of them, and I'll hold this up here. So one of them we've got connected to a light switch. Just want to be careful so none of the cables unplug here. So here's just a light switch, just a regular light switch. It's got a couple cables going into the Raspberry Pi board. So the Raspberry Pi has these controller pins here that let you do input and output from the board. So we've got these cables going into the switch, and they go in and they receive a signal whenever you toggle the switch. And on the other side, I have the light here. Similar thing, another Raspberry Pi here, and a light here with the cables going in. And this one is doing kind of the opposite. With the switch, it receives a signal when you toggle the switch. With the light one, it controls the light. It activates a relay to let the electricity through or not, and let you control the light. These two are not connected in any way. I mean, they're here on the desk together, but they're not really connected to each other or interacting with each other. And they could be on separate parts of the world for all intents and purposes. So what I'll do is I'll just first show you the local demo with SSH. So I open my terminal window here, and I have an SSH terminal open onto the switch with the toggle here, and I've got a command that I can run, and that's going to start a little program that's running on this, what is basically a little Linux box here. And now it receives a signal whenever I toggle the switch. So you might not be able to see me do it, but as I flick the switch on and off, the program receives that signal and then just receives that event, and you can do whatever you like with it. And so right now we just write it to a message to the screen. But you're in a programmable world. You could do whatever you wanted. You could do something on the screen if you had a screen connected. You could do whatever you want with that event. Similarly, on this tab here, I've SSH'd into the light. So I run a similar command. What this one's going to do is run a Java program. It doesn't have to be Java. We've just chosen Java. And it's going to turn the light on and off a couple of times. I'm not controlling it in this case. It's just there's a timer in the program that just turns that on and off a couple of times. So that's just showing that we can write a little program and receive events from the switch, and we can control the light. But we haven't done anything remote yet or with WebSockets yet. So let's see what that looks like now when we introduce WebSocket into the picture. This is a high-level overview of the architecture. So the top part there, we see the switch and its Raspberry Pi, and the next one there, we see the light and its Raspberry Pi. And both of those, we've taken those two programs on there and modified them so that instead of writing a message to the screen when you toggle the switch, it will instead publish a message to a JMS broker. As Frank talked about, WebSocket is really a transport protocol for other protocols. We've just chosen JMS in this case. Didn't have to be JMS. Could have used AMQP, XMPP, something proprietary that we made up, whatever you wanted. We just happen to choose JMS in this case, so don't get too fixated on the fact that it's JMS. So we've modified the switch so that it can publish a message over WebSocket into our Kazin gateway, which is now communicating with the message broker or the message bus behind it. I've written JMS over WebSocket there to show that we're transporting JMS messages. JMS is not really a protocol, but just for simplicity, I've just labeled it there as JMS over WebSocket. So what I'll do is, I'll go back to my terminal, and I'll start a different program this time. So on the light, I'm starting a program that's going to sit there and listen for JMS messages. And then on the switch terminal, I'm going to start a program that will, when it receives an event, a signal from the switch, will publish a JMS message. So now I can toggle the switch, and the light goes on and off as I toggle the switch. Okay. Going back to the architecture, I've sort of overlaid what that might look like. When the switch receives a signal, the Raspberry Pi receives a signal from the switch, it publishes a JMS message. In this diagram, it's shown going over the web. In reality, because of the constraints with the network here, it's going just over to a local router that I've got running here, and the JMS broker is running on this laptop right here. But in principle, it makes no difference going over the internet, and usually when we would do this, we would do it over the internet. And I have another demo coming up in a moment that is using the internet. So it publishes a message, it goes over the WebSocket, into the gateway, hits the message broker, and now it gets sent to any subscribers that happen to be listening for that message. The publisher, the switch, has no idea who's listening, has no idea if the light's there or not. It just sends a message. The switch has no idea where the message comes from. It just so happens to come from the switch, but it doesn't know. So the broker sends that out through the gateway, over the web, over WebSocket, into the switch, receives the message, and now activates the light. Okay? The next step is, so, okay, now that we can do that, let me add the computer in. So what I've got here, running in a browser, is a sort of debugging sort of demo app that we use for JMS. And it lets me connect to this is running in a browser, it's just JavaScript right now. I connect to my broker, I join the channel or the topic that I want to listen on, and I subscribe. So now, as I toggle the switch, I should receive a message from the broker. Did I hit subscribe? Oh, there we go. Sometimes it just takes a while to warm up. Okay, so now as I toggle the switch, the light goes on and off. And if you look at the output over here on the right, I can see that, let me hide the headers here. I can see I've got an on message, an off message, an on message, and as I toggle it, I get another message there. If we see what that looks like in the diagram, the light is publishing the message over WebSocket, comes back through, and we know that there are two subscribers now on this topic or on this channel, and they both get the message. So the light got the message and switched on, and my browser got the message and chose to display it on the screen. Okay. If I go back to my little application here, I can also publish messages from here. So if I send a message that says on and send that, I now activate the light. If I type an off message, okay, the light goes off. So looking on the diagram, it looks something like this. We saw the switch is only a publisher and the light is only a subscriber. But there's no reason clients can't be both, a publisher and a subscriber. Okay? And that's what this is. I also have, that's a sort of a bit of a, debugging app, but I also have a more friendly application here. So now I can just press on, press off, and control the light. And if you were looking over here on the log window, sort of behind there, you'll see that messages will be arriving there as well. That's scrolling up and down. Okay. I talk a lot here about messaging because whether you explicitly use messaging in your application or not, you're ultimately doing messaging. As soon as you have an application that's sending certain data to certain people, you're basically doing messaging, whether you call it that or not. So you get certain advantages if you use a messaging system that does a lot of that work for you, rather than you having to write the code. You get a lot of flexibility as well, because you can add publishers and subscribers, and you don't have to change your architecture, and it just gives you a lot of freedom. There's a lot of benefits to messaging. So that's why in these examples like this, we end up using messaging. So yep, taking that a step further, I've got a phone here. I can't project what's on the phone, so what's the code? 3861. So what I'm going to do is open up the same application as this, the one with the on-off button there. So I'll try and make it a bit, not everyone's going to be able to see this, but it looks the same. It's just got the green and red button there with the light bulb. And now I can control the light by pressing the on button here, pressing the off button, on, off. Okay. So it's the same application, the same page, just JavaScript in this case. There's no reason why that could not be embedded into, could not be part of a native application. We're just doing it in a browser page just for convenience. Okay. So this is to show that, you know, with WebSocket, it's not so much the WebSocket itself that's important, it's what you layer on top of it and how you use the thing that's on top of it. So here we're showing using a WebSocket connection from a physical device, from a browser on a PC, and a browser on a phone, but also basically it'll be the same as doing it from an application on the phone. And just to make it look like spaghetti, you know, that's kind of showing that where the publishers and subscribers are. Okay, so now the second part, so that was on a local network, but the fact that if it goes over the internet makes no difference, it's just a network. So we have another demo here. What I've got down here is a remote control car. It's just from a toy store, it's just a regular remote control car. What we've done is, have to be a bit careful here now, but there's a little Raspberry Pi on the back there that we've taped on very insecurely. So you know, we threw away the remote control, and somewhere in this car there's a little thing that receives instructions from that remote control. And instead we've got cables going from the Raspberry Pi into that thing, and now we can control it in the same way that we were controlling the light. So I'm going to use my other phone now. So this is connected to, I've got an internet connection here, and I've got an internet connection here as well on my phone. So these lights probably aren't very bright. I can control the lights on the front. Yeah, they're not very bright. So I can turn the front, I can turn the wheels, or I can sort of spin the, I could get forwards or backwards here from the phone. So I hold it up like this. So I've learnt the hard way. Driving around on the stage can be pretty tricky and can have unintended consequences. And plus it's a bit hard for everyone to see. So I just hold it up. So I'll just do that again. So press the button there, you know, and spin the wheels, okay? So that's actually going over the internet. In this case, normally when we do this demo, I wouldn't be using the phone. I'd have a colleague back in the office, and we'd be talking over Skype, and he would be controlling from the office. But because there were some networking constraints here in this room, we weren't able to get that done. But that's what the slide, that's why David, the two guys who created this demo, David and Prashant, would be back in the office, controlling the car from back in the office. They're the ones who initially created this demo, and once we realized they're pretty smart, so we don't let them leave the office anymore. And so now I go out and do the demos, and they have to stay back in the office. Oh yes, so well, I suppose I'll leave that up. This is the final slide. What I want to show here is that the truck is here in San Francisco. They would have been in Mountain View down south, but they could be really anywhere on the globe. The server in this case is on the East Coast. So when I press the button on my phone, that message is doing a WebSocket connection to the East Coast we're using Amazon, so just an Amazon instance there. And then it's going through the message bus, coming back around from the East Coast back now to the truck, which is receiving that event and then spinning the wheels or doing whatever. Okay? And you know, I wanted to point out that the code, there's no code, even though the gateway there looks like it would be where an application server or some sort of container or web server might be. There's no code deployed there. It's just a WebSocket listener, and it facilitates the conversation between the client and the broker. So the code is on the, in this case on the card, there's a little Linux, box on that Raspberry Pi running a little process. And it's just your application code and a small amount of code that sends and receives JMS messages. Otherwise, it's just your application code. And same thing on the phone. It's just application code. That's the GUI, with those buttons and a little small layer that can just send and receive JMS messages. So it's a very simple architecture. We're showing that, the Internet of Things is a very popular topic right now. Internet of Things, it often implies TCP connectivity. So we like to talk about Web of Things, where when you bring WebSocket into that, you can now run any protocol you want over the web, not just TCP, and not keeping you just constrained to what's traditionally in the enterprise only. So it's another reason why we use a message bus or a message broker here. The idea of a message bus, that asynchronous event-driven architecture, is very well known, very popular, but it's traditionally been locked in the enterprise and hasn't escaped out into the web. And so now with these new standards and new protocols, we can extend those to the web and have these clients out here participating, interacting with that message broker as if it's connected directly, running over top of WebSocket. Okay, thank you.
So I think we might have time for one question. If anybody has there are 2 mics there.
We'll be here after at the booth. They can come to the booth as well.
Well, hello. So building a web application, you would want to support as many browsers as possible. WebSockets are not supported in the old browsers. How does your product, and in general, what's the recommendation for it?
That's a good question, and it's typically, actually, just before I answer that question, so if you guys want to see the car in more detail, we have a booth over here. You could stop by and check out the car. We talk to you more about what we actually did specifically on the car. So you're right. Not all browsers support WebSocket natively, and also not only the browsers, but between the browser and the server, there are some intermediaries that might not be friendly to WebSocket. So even though you might have a modern browser and a WebSocket server, you still might not get WebSocket across, right, across multiple hops. I used to work for an investment bank in New York, and the server was across the street. We had 15 hops to get to the other side. So in practice, you got to be careful. Like, you don't assume that you're going to have physical WebSocket, even though you think you have physical WebSocket. So there are ways, and some open source tools fall back to HTTP when they detect that situation. So, pardon me?
Long polling?
Yeah, typically long polling. That's the typical. I mean, most things fall back to long polling.
We don't.
We don't. And, this is more of a salesy marketing thing. So if you want to find out more information, I want to keep this more technical. You just stop by the booth and I'll explain to you exactly how we do it. So we don't fall back to long polling. So we emulate WebSocket in older browsers. Stop by, I will tell you how we do it. You have this?
Hi. I've implemented sockets using Node and Sock.js. Can you just give me a basic idea why I would do it with you instead of that kind of implementation?
Yep.
And maybe that's a marketing thing that I should come to your booth, but if you could just give me a...
It is a little bit, but the crux of it is that, yes, WebSocket's cropping up everywhere, getting a lot of traction. There's a lot of open source projects and free servers and application, frameworks that will use WebSocket. One of the things Kazing brings to the picture is the productivity from writing very little code, very little amount of code, but also the enterprise robustness. We're focused on enterprise applications. And what we've seen and learned is it's one thing to build a WebSocket application and get something working, and even get it working pretty fast and get it performing pretty well. But that's a long way from doing that to now being a global bank that wants to globally scale this application to work in many environments with high scale, high throughput, with all the robustness you expect for enterprise app security, load balancing, failover, and all those kinds of things. So if you're just building some small app and you don't need those things, then yeah, they're perfectly good solutions for that.
Got it. Thanks.
What are the power consumption issues on mobile devices? Is this a persistent connection from a mobile device to your server, WebSocket connection? Is there something that can optimize on it, or is that part of the protocol?
I didn't hear the question.
Yeah, I'm not quite sure I understand your question.
If you're opening a persistent connection from a mobile device to a server,
Right.
which is a WebSocket, I imagine, is there any power consumption which happens on the device to maintain that connection, or is that part of the protocol?
Is there any what on the-
Power.
Oh, yes, that question comes up a lot. A lot of people think, oh, WebSocket persistent connection, that's just going to suck the battery dry of the phone, So it's actually not necessarily true. So we've done testing and we've investigated this, and we found that when you understand how the phone works and you understand how the different energy levels in the phone work, you can use that connection wisely, and we found that we can actually extend the battery life by 50% compared to a traditional HTML application, a HTTP application doing the same work. So same volume of data, and the battery lasts 50% longer with our connection. That comes with, that's like the other gentleman's question, that's some of the value that we bring, that we know how to do this. So it's not an automatic assumption that having that persistent connection will drain the battery life, although a lot of people instinctively think that at first.
One more, is there an open source project which can, or some kind of library which can help us do this, or is that only something that Kazing has done?
That's, something that we've done.
Okay.
So.
Thank you.
But, all these Kazing questions can be answered at the booth.
Yeah, I'd like to keep the...
Happy to talk about it there in
I don't
more
want
detail.
to turn to the marketing thing. You could stop by our booth and we'll put our marketing hats on then.
Hi, nice demo. I want to buy the car for my kids, but that's a second thing. In all your demos, you had to connect to a server, right? And so I want to ask if there's a way to discover services like the light. Could you discover it? Do you have a mechanism for that, or because WebSocket could be like peer-to-peer, really?
That's right.
Oh, I see what you mean. So you're asking for sort of like how do I discover other services out there that are WebSocket capable? Like a repository, like a REST repository you can query, do you have this?
Not necessarily. It could be dynamically in a local network, for instance. Like something similar, the light bulb and the switch reminds me of UPnP. In UPnP, you have light switch, you have things like that, but it's all about like broadcasting the services, announcing the services, and discovering them. I'm not aware of a similar mechanism on the web. And,
Yeah, so I think that introducing WebSockets doesn't change the challenges you have with discovery. And the way that you would solve it in any other context, you would solve it in the same way with WebSocket.
Thank you.
So I wanted to understand what kind of performance implications WebSockets can have on your application server. So, let's say if you have up to 1,000 clients connected, and the app server could be, let's say, Tomcat.
Yes.
Now, does that mean 1,000 threads are just burning, waiting for messages?
No. No, WebSocket has the capability of having good performance, but you have to have a good implementation. Just by using WebSocket doesn't magically mean that your server could handle thousands and thousands of connections. There are going to be good WebSocket servers out there and bad ones out there. Some that can scale well and some that cannot, and that's how they will differentiate themselves. So it comes down to the implementation of those servers.
Any comments on the Tomcat implementation of WebSockets?
It's not as good as Kazing's.
I think we're out of time, so if you have any other questions, we have a booth there. Please stop by, we answer. And now for the coffee break. Thank you.